Hi, and welcome back. You've just now completed the Foundations section, and hopefully you're on the other sections, such as the AWS Academy courseware, such as SysOps, DevOps, as well as the Solutions Architect modules. If you completed with all those, you can continue to the bonus section. I highly advise making sure you finish all your required modules before continuing with this section. With that said, my name is Dennis. This is the Using AWS CDK and Terraform portion of our bonus section. Let's get it started. Our learning objectives today include understanding the differences between the use of CDK, Cloud Development Kit, Software Development Kit, or SDK, and Terraform. We'll learn to install and deploy CDK as well as Terraform stacks, and then you should be able to create custom construct patterns for reuse on either stack. So first, more about AWS SDK. All throughout this course, you've utilized the Bodo 3 Python SDK client for some of these Lambda functions. You might use them for serverless requirements or creating infrastructure as code, depending on your use cases. We just want to make sure that you have all the fundamentals down and get some extra additional tips on development using the SDK, and particularly with Bodo 3. Again, Bodo 3 is the Python version, and it's been ported to Python 3 as the newest and latest requirements. Here we have an example Lambda function. Now, the most important part is that we don't want to use hard-coded tokens or hard-coded keys ever. Now, how do you actually utilize the role or assume a different role while you have an AWS Lambda function from within? That's a great question. Make sure you have the STS assume role privilege and the policy associated with your execution role. You can also define the actual session token information using the information that you see here. For instance, let's go ahead and take a look at our Lambda function code right here. Right here, I define that we have a STS connection assume role method. I attach that using the client that I created, and say for account B in this case, I want to assume the role inside account B, and that is the ending ARN with my role information. I give it an external ID such as a secure string value, hopefully unique enough outside the course of this requirement. You can give your role such a name so you can easily identify it in logs such as CloudTrail. Next, create another stanza. We'll create additional variables, and this should look familiar, such as the AWS STS get session token. You should get the access key, the secret key, and the session token that is temporary in nature. You can utilize your client and specify your three variables right there from at that point. Assuming you have both roles, as well as the acquired privileges and policies attached via the trust, you should be able to utilize the role and utilize your STS token instead. Never had to encode hard-coded passwords or other values. Now, along with the SDK, you also have two different types of the API. You have the low-level client-level API that allows you to have the most control and allows you to have flexibility in case you didn't want to utilize an abstracted version. The resource level is the recommended level for most developers. This is because that you provide the best projects and objects applicable to your abstraction and methods. Notice the difference between the two clients for the same exact thing. I have to specify a client, a response, and then utilize the iteration to grab the buckets. However, instead of using an extra for loop and having to understand how each of these iterations work and how the outputs of each items are, I can utilize a resource-based method instead, and it has that method predefined for me, reducing my code and reducing complexity at the same time. Now, here's an example of Bodo 3 use case that you should utilize and consider. Let's go back to our previous example here, a resource versus a client. And one thing I want to mention before we get off the slide is that it's not multi-thread, right? If you need something multi-threaded, use the client level and integrate that in your coding accordingly. If you're going to use a resource, if you need to use something that's multi-threaded, you cannot use resource level directly with multi-threaded experiences. You must create a new process each time or create a new thread for each method. Now back to our initial use case. Let's say with the SDK, I needed to go ahead and utilize an EC2 instance that patched every night. We had very good security. For whatever reason, we needed to reboot for every single patch, and as a best practice to make sure we clear out any temporary caching or log files created because we haven't been able to refactor quite yet. I can utilize the Boto 3 client and go ahead and create a Lambda function and schedule this Lambda function to reboot my instances based on certain criteria, such as tagging or, if necessary, using auto-scaling criteria using the SDK, understanding what the symbols look like, as well as the CloudWatch events integrate with my AWS Lambda. All this is and more, and remember, everything with AWS is an API call. The SDK is no different. Whether you do this in the console, the SDK, or the CLI is all the same thing. This is just one example of what you can do with further automation using Python and the Boto 3 SDK. Let's take a quick break, and then we'll go back to understanding more about infrastructure as code, as well as using delineations between SDK, CDK, and Terraform. All right, welcome back. Let's go ahead and get started on infrastructure as code concepts. And remember, infrastructure as code is one of the best practices, as well as the patterns that you want to accomplish inside AWS or really any cloud environment. What does that look like to you? Well, think back to some of your other lecture modules. CloudFormation should bring a hint. The SAM toolkit, such as the Serverless Application Model Framework, and many others. We'll learn about two additional abstractions right now. The first one is Cloud Development Kit by AWS, otherwise known as CDK. We have the idea of a stack, which is the same as a CloudFormation stack, and you have a construct. So every time you create a pattern, which is one or more services, you create a construct. The construct is based on what is connected. So, for instance, here I have two constructs utilizing two resources each. The first construct means SQS and Lambda are connected together, while the second construct, I may not need to have a pattern of S3 talking directly to DynamoDB. However, they do exist. Each of these is a stack, stack 1 and stack 2. The construct just means you have a pattern of one or more services, whether they're connected or defined via separately in different parameters. All this is using the Python syntax and language. CDK must be installed, and so you can initialize it once installed using the npm package manager, CDK init, sample app language Python, so you can understand what those constructs look like. Other languages are supported, such as TypeScript, JavaScript, Java, .NET, and of course, our favorite, Python. Here's one example of an Elastic Container Service construct looks like. Notice that it has the same exact Python parameters and capabilities. If you decide to create your own construct, you can always utilize a sample template instead, which allows you to give this initialization that you're looking for. You create each construct object inside here via the stack, and this is my initial core stack. In this case, I have to create a VP, and it doesn't matter what the order is. I can create a VPC, reference the VPC, and then finally create my ECS patterns based on that. Now, order from a Python syntax perspective makes more sense rather than the CloudFormation order. This is because if you reference something that is not currently initialized, you're going to get an error just like everything else. So remember that you have to understand your own order of where variables are referenced, such as VPC is now referenced right here, has to be ordered first. Look how easy it is to have a few lines of code and to define an entire ECS pattern right from the fingertips. Without having to deploy and understand what it looks like in the console, you have all this in a pattern for yourself. Now, Terraform is a competing product. It's more mature than CDK at the time of this recording. It also has multi-language support, and originally it had its own HashiCorp language scripting. It looks like JSON, and it uses key value pairs. At the time of this recording, there's also a CDK for Terraform, which allows you to utilize Python and other constructs in Terraform context. Now, why would you use this? It depends on what you're trying to do. If you already have Terraform in your environment and you're a multi-cloud vendor, maybe CDK makes a lot of sense for those that are converting over or only know AWS. In terms of Terraform itself, because it's another scripting language and it creates that level of abstraction, you can actually provide this against many different service providers instead of just AWS. That's the real advantage of having infrastructure as code, and you should know this before walking into any kind of exam or practical when you're looking at infrastructure as code when you're out in the job market. Here's an example of an EC2 block. Now, the same as construct is to CDK, EC2 is Terraform is to block. And we define our Terraform stack right here, including which is the provider, such as AWS in our case. Now we provide the information about our profile, and then ultimately we define what we have an instance that we want deployed, as well as any kind of tagging or other methods and mechanisms. That's all there is to it, and know that this is another just version of infrastructure as code. Now, regularly I would do a demonstration of all this, and I'll do a demonstration quickly of CDK itself. However, you'll do this in your labs, and I want you to discover for yourself the power behind infrastructure as code, whether it's Terraform or CDK. Make the best choice for your stakeholder, not based on what you know. All right, let's take a quick break, and then we'll come back for a demo. All right, welcome back. Hope you had a great break. Let's go ahead and do a quick demonstration of the power of CDK itself and how you can deploy a sample application. Hopefully, this will bootstrap you a little bit more. To install your package, make sure you have npm installed. Now, I'm not going to install this for you. However, you can go ahead and make sure that you have CDK properly running. CDK tactec version, and you should have a version returned back to you if properly deployed. Remember, once you've installed your npm package, you might have to close the window and reopen it to make sure that the variables are in there. Now let's go ahead and create a new desktop, switch to a desktop folder, make a new directory, CDK temp. I'll go into here just to make sure I have all my temporary files there. And then as a general best practice, I'm going to go ahead and initialize my app. And I'll create a language and define my app template Python. Now, as you look here, look at the different items that we're doing here. It's creating a virtual environment using the venv module. Think back, weren't we always using this with Python? You're right. As you can see here, we created a series of items. Because I'm in PowerShell, I'll use a dot. I'll define my activation script. And now you can see my virtual environment has been activated. Let's go ahead and take a look at what this looks like. And I'll grab the information that we just did. And 1 second here. So let's go ahead and look at our application stack right here. And we see that we have our initial creation. And this doesn't look like the construct I showed you on the screen. This is because this is the outside application initialization portion of this. You can define different variables for your actual application stack, and this is what will be bootstrapping your additional code. If you go to your CDK stack right here, this is actually what you'll define as your construct. Your code goes down here for what you're looking to do. All right, so let's go ahead and get started here. Let's go ahead and create the following statement. We'll use our items here, and I'll do a quick item, which is CDK ls. Do we have stacks? And we do not have a stack yet because we haven't defined anything. So first, for now, let's go ahead and make sure we've activated everything. And then we install our requirements. Let's look at our requirements using cat or type. Our requirement is saying, hey, whatever's in the environment so far. So let's go ahead and pip install our requirements. As you can see here, it's downloading all the construct and information that I need to run a CDK app deployment. And now we have a series of information right here. And we've seen this as we've grown our packages. Now let's go ahead and do a CDK ls again. Now we have a temporary stack that has been created. Let's go ahead and make sure we add the appropriate one, which is we're going to create an S3 bucket, for instance, aws-cdk.aws-s3. Oh, and it would help to spell it correctly. Now that we've installed all of that, let's go ahead and go into our directory here and understand where we're at. So let's go into our CDK temp, and we have our stack right here. Let's go ahead and just open that quick. And because I want to go ahead and do this in a nice little editor, I'll do this in like Notepad++, or you can use VS Code for yourself. Now, as you're doing the workshop, the instructions will be a little bit different for you. Just keep in mind that ultimately this is about understanding the concept behind infrastructure as code. We have our application bootstrapping information here that we don't want to change for now. And inside the CDK temp folder is what we define as our app itself. And notice that we have our PyCache, which is our library information here. We'll have our CDK temp stack. And here is where we can define our Azure pattern. We want to go ahead and say we want to define our S3 right here, which is import from AWS CDK package S3 as AWS underscore S3 as S3. From here, I want to go ahead and create a new bucket. We'll say bucket equal S3.bucket self. And then I can also create my first child bucket, and I'll put my area code here just for uniqueness. I'll even say versioning is enabled. Looks pretty cool. Now let's check our save and check our code by doing a CDK sync. Now this will convert. This should convert everything in there in a command line or JSON. So let's figure out what happened here. Looks like I'm not in the right directory. Let's go back into our app.py directory, and where our JSON is ultimately, our CDK JSON is as well. All right, so let's do a CDK ls. Yeah, yes, it found it. And that's because we edited CDK temp underscore stack pi, which is going to define our first construct was a bucket that I just call this string right here. All right, so let's go ahead and do a CDK sync. Now we have all this information here, including what would be created, what's the name, and this is what the CloudFormation equivalent of this would look like if I had to type this all out myself versus that one little line I would put inside my CDK application. That's a lot of difference. Okay, let's do a CDK deploy. And normally you would do a CDK bootstrap. But in this case, it'll go ahead and bootstrap this for me in the first set here because it's minimum. Now this is going to take a little bit, so I'm going to pause the video, and while it's created, we'll go, oh, looks like it finished for now. Well, I'll still pause the video, and let's wait till it finishes the entire output, and I'll show you what it looks like inside the console, and how you can actually do a destroy it using infrastructure as code best practices. All right, welcome back. That was fairly quick. I had to wait about 20 seconds or so. And now it's created a CloudFormation stack, a bootstrap bucket, and my other additional information. Let's go into my console. And then we have this ARN here that says what my stack is. Great. So let's look at my console. I am in US East 2, which is what it says here, along with my account name, or account ID. I am in US East 2. Let's look at S3 and see what my buckets look like. Notice that we've created two items here. A bootstrapping bucket automatically as part of CDK deploy, which contains my CloudFormation objects and artifacts. I also have, we also have my first child bucket here, also part of that. And to see if we have versioning turned on, we have the items right here and the properties, and versioning is indeed enabled. It's also got tags to say I'm part of the CDK CloudFormation stack. Now, if I go back to CloudFormation right here, it's also going to find my stack, CDK temporary stack, that I've deployed. So the one thing to keep in mind is I mentioned that you should use CDK Bootstrap whenever possible. Utilize CDK Bootstrap and we'll actually hold the artifacts of the caching of the synthesized CloudFormation item right here in a separate S3 bucket as opposed to creating your all-in-one bucket versus on CDK deploy. The best practice is to always use CDK Bootstrap before you do a CDK deploy. Keep this in mind as you're going through. And then regularly you could do a delete right here. I'm not going to do that. The best practice, again, is to utilize where you came from, which is CDK right here. So CDK ls. And we want to destroy the stack. CDK destroy. Yes, I want to destroy the entire stack. Now all of that I just created will still be destroyed right here, and now it's complete. We'll go back to my console right here, refresh, and now it's completely gone. Going back to check the S3, making sure we don't have any leftover artifacts. And unfortunately, because I did bootstrap, and CDK must always bootstrap, the bucket is still here. Now your other S3 buckets that you create outside of the bootstrap should be deployed and destroyed upon the deployment here. You should always delete the bootstrap bucket for the initial deployment. So go ahead and delete the bucket here. Now, a temp stack or bootstrap bucket is exactly what the bootstrap means, and you'll always need to delete this manually right here, along with the bootstrap stack itself. All right, that's your introduction to CDK and how you can create infrastructure as code and skip the CloudFormation template and go utilizing constructs within the Python context really easily. Here we go in one line. That's it for now. We'll see you in the next lecture.